So welcome everybody to this latest video on 162 Math, and in this video we'll be looking at the theme of algebra with a focus of simultaneous equations, where you've got one equation that's linear and the other that is non-linear. Now, prior to this particular topic, you will need to know how to solve quadratics by either factorizing or by using a quadratic formula. And so if you haven't done those two topics, please watch the videos, and I'll include some links in the description below where you can find how to learn each of those topics. And as always, I'll try and include some notes and a copy of the question paper of the questions that we go through in this video in the description below for you to download and have a copy for your own reference, but also for your own attempts while watching this video. Now, when we have two unknowns, and this is known mathematically as variables or visually known as letters, we need two equations to be able to find the value of these variables. Now, if we were to plot these equations on a graph, then the value of these variables would be the ordinates of the intersection points. Now, before we were only using linear equations, so where we only had single x and single y, thus producing straight lines. And there was only ever going to be one set of solutions as long as the lines weren't parallel. So, for example, when we looked at simultaneous equations before, you probably ended up with 2x minus 3x equals, let's say, 18, and 3x minus 4. Oh no, let's correct that because I forgot a y. So before we had 2x minus 3y equals 18, let's say, and 3x plus 5y equals 27. So here you can see we've got a single x and a single y in both these equations. Now, if we were to plot those equations, they would simply be straight lines. So again, what you're probably most likely going to have is something that looks like this. And then if I change the color and a bit of faff, and let me just, yeah, and let's say I had this here, then my x value would be this number here, and my y value would be that number there. And likewise, if we had something that was, let's say, in some of the other quadrants, so let's say we've got two equations there, then the answer would be this here would be my x ordinate, and this here would be my y ordinate. So when you're looking at basic simultaneous equations, that's one of the reasons why you probably only end up with one set of solutions, because when you plotted each of the respective equations, they would only intercept at one point. And again, as long as they weren't parallel, because again, if I just get rid of all of this without deleting the axes, if I had two parallel lines, then clearly those lines would not meet. So there would be no solutions because obviously the lines don't intersect. Now, however, if we have one of the equations that was non-linear, so in other words, not straight with multiple powers of x and y, and in fact a parabola or a curve, then we will have multiple solutions, including no solutions at all if the other was linear. So looking at this, if one of the equations was, let's say, a parabola, and here we've got a positive parabola and a straight line, then you can see here that I'm going to end up with two solutions. So this is going to be one set of solutions. So let's just call that A and A. And this will be, let's call that A1, A2, because they're going to be different numbers. And this here would be another set of solutions. So let's call that B1 and B2. So here you can see I'm going to end up with two possible answers. And likewise, if I had a negative parabola and a straight line, then again my solutions are going to be this coordinate here and this coordinate here. You could also have ones where, for example, if I draw another curve, it doesn't need to be a parabola, it can just be a curve. And let's say I draw a straight line, which is not that one because that one does not meet. And so, oh, that's definitely not straight. What am I doing? Right, so here, and let me just correct that. It might be easy if I did the curve first. Like so. So here you can see we've only got one intersection point, even though we've got a curve and a straight, or what resembles a straight line and a curve. So here we're going to have one solution. So don't automatically think you're always going to end up with two solutions. You could end up with one. You could also end up, so if I just draw a parabola, it doesn't always have to cross the axes. And let's say I've got a straight line. Now that red line is never going to intercept the blue line, even if we were to extend each of those lines, they would never intersect. So there is a possibility that we could end up with no solutions because there are no intersection points. Now, I don't really need to go into much detail about this because the number of solutions refer to a mathematical topic called the discriminants, and this is a topic that's on further maths or A level. However, by looking at the number of solutions, we can determine the property of the line to the non-linear line. So for example, when you work out your answer and you've only got one set of answers, then that would mean that the linear equation rather is going to be the tangent, and if you end up with no solutions, then it means that the curve and the straight line do not intercept. So even though you may not get asked to work out the number of intersection points, you may get asked to interpret your answer, and if you've only got one set of answers, then it means that the straight line is going to be a tangent, and if there are no solutions, then it means that the curve and the straight line do not intercept. Now at GCSE level, you're only ever going to be dealing with a curve, one curve and one straight line, or two straight lines if it's a basic simultaneous equation. And odds are you probably won't be getting a cubic graph. It'll usually be in the form of either a circle or a parabola in terms of that, because they're the only two sort of topics in GCSE syllabus where you are going to be dealing with such equations. You can therefore get, let's say, cubic graphs if you're studying further maths or A level, but again, so I don't want to say that it's never going to be a possibility, but at GCSE level, the only equation you're going to get is either a linear equation with either a quadratic or a circle. So let's just quickly go over the method to solving a simultaneous equation where one of the equations is non-linear and one of them is linear. So the first thing you want to do, and again, if these steps make absolutely zero sense, do not worry. When we go through some examples, hopefully we'll go through each of these steps and show you how you can maximize your marks. So the first thing you want to do is to, in the linear equation, so the one that's just got single x and single y, it's probably the one that looks the most simplest, is you want to make one letter the subject. Now in more higher mark questions, you may have to do a bit of rearranging. In let's say a lesser mark question, this will already be done for you. So question one, or step one, is going to be very optional based on the types of questions you're given in the exam. And again, we'll go over this when we go through some example model exam questions. With step two, what you then want to do is substitute the linear equation into the non-linear equation, so that again we've only got an equation that involves one letter. So typically you've got an equation that involves two letters, so x's and y's, and what you want to do by substituting, you just want to have an equation that involves just x's or just y's. Then with the third step, what you then need to think about is quadratic equations. So hopefully you can see the components of a quadratic equation, but it's not quite in that format. So what you need to do is try and make the equation equal to 0 and simplify by collecting like terms where you've only got three terms. So you've got something with a square in there, something with a single x or y, and then a constant in there. That might not always be the case. Maybe the x's might be missing or the constant might be missing, but you should end up with something that looks like that. Then step 4 is then solve the quadratic by either factorizing or by using the quadratic formula. Please do not use completing the square, although if that is your preferred method, that might be fine. But again, the examiners will probably be expecting you to use one of these two methods. And also, if a question says give your answers to two decimal places involves anything of rounding, do not waste time trying to factorize. It's going to be straight a quadratic formula. If there's no mention of rounding, then it's going to be a good chance that the equation will factorize. Then for step 5 is then once you have the values of one variable, so either x's or y's, you then want to substitute these values into the linear equation. You can substitute it into the non-linear, but again, you're just making more work for yourself. So by substituting it into the non-linear, you can then therefore solve the equation to find out what the respective other variable is going to be. So if you've substituted x values, you then find the y values, and if you substitute the y values, you'll then find out what the x values are. And then finally, what you then want to do is write down your set of answers exclusively or as a coordinate if it's related to a graph or the intersection points. Now this is really important because, for example, and again this might not make any sense if you've not ever seen this topic before, but if I worked out that x was 2 or let's say -5, and then I then work out that y is 10 or -12, I don't know which pair of coordinates go with which. Does the 2 go with the 10 or does the 2 go with the 12? So what you want to do is write them close together. So x equals 2, y equals -12, and x equals -5 and y equals 10. So you just want to write them exclusively like this, or you could write it as a coordinate if it relates to a graph. And there you go, because obviously this is the x ordinate, that's the y ordinate, that's the x ordinate, that's the y ordinate. It's pretty self-explanatory. Now the key thing to note is that these questions are always worth lots of marks. I've seen questions up to 6 or 7 or even 8 marks in some exam papers. So it's really important that you focus a lot on your working out. Try not to skip too many stages, because if you do that and you've made a mistake, and you won't know you've made a mistake, it's easier to find a mistake if you have showed clear working out and detailed working out as well. And again, when a question's worth 6 or 7 marks, that's almost going to be 10% of your paper. So it's really, really important that you do show clear working out. So now let's have a look and go through some past exam questions. Now again, if you're wanting a copy of these questions to either have an attempt at these questions before watching this video or while watching this video, then all you need to do is just click on the link in the description below and just download the document, and you'll have access to these questions. So let's have a look at question 1. So question 1 is worth 5 marks, and it says solve the simultaneous equations. So here it doesn't give us a clear explanation that it's one linear, one non-linear, but again you should be able to spot that we have got a power, so therefore it's going to be a much higher level than what we're used to. Now in terms of step 1, as you should be able to spot, so this first equation is my linear equation and this is the non-linear. So from this, as you can see, that in the non-linear equation I've already got y the subject. So what I'm going to do then, so step 1 is already done for me, there's no rearranging for me to do. Y is the subject, so that's great. So what you then need to do is, because as both of these equations are equal to y, I'm going to make them equal to, they must mean that they're equal to each other. So here I've got 10 minus x equals 2x squared plus 4. So that there is my step 2. Now, as you can see, what I then want to do is then turn this into a quadratic. So I want to make it equal to 0. Now, it makes more sense for me to take the 10 minus x over to this side, because I want to try and keep my power of x positive. So then by doing that, I end up with 2x squared plus 4 minus 10 plus x, and that all equals 0. Now, what I'm going to do is I'm just going to flip that equals 0 to the other side, because it doesn't really matter which side the equal 0 is going to be. Then if I neaten all of this up, I get 2x squared plus x minus 6 equals 0. Now from this, what I now need to do is to factorize. And again, it depends on however you want to factorize. So for this, we should end up with 2x and single x. And we're going to go for, I think it's going to go, so let's go for, we need 1. So there's going to be, so let's go for 3 and 2. And because we've got a plus, I want, that's going to be a plus there. And this is going to be a minus, and that equals 0. Now, if you're not sure about how to factorize quadratics, then I'll stick a link in the description below, which shows you how to, the most easy and effective way of doing this. I've done this mentally, but again, you can find other ways of solving this equation. So you can use a quadratic formula if it's on a calculator paper, but again, it's entirely up to you in terms of how you do it. But this would be where we're then solving by factorizing. So here I get x value, and it's going to be 3 over 2 or minus 2. So these here are my x ordinates of the interception points. So then what I then need to do is look at the linear equation, which is y equals 10 minus x. And then I substitute my first value, so x equals 1.5 or 3 over 2. So y equals 10 minus 1.5, which equals 8.5. So that's there my first set of coordinates. So it's going to be 1.5 and 8.5. The next one is then where I substitute x equals minus 2 into there. So I've got y equals 10 minus minus 2. So y equals 12. So that's my second set. So when x equals minus 2, y is going to equal 12. And there is my final answer. Now the question's been quite nice in the fact that in its answer space, it's actually given me answer easier for me to remember that I'm writing my answers as sets of numbers, not just like a mixture of 4 numbers merged together. So there are my 2 sets of answers. So moving on to question 2, it says use algebra to work out the x ordinates of the point of intersection of y equals 3x squared and y equals 4x plus 2. Give your answers to one decimal place, and the question is worth 5 marks. So again, looking at this, well, let's have a look at the key bits of information. So this question, it says use algebra, which basically means use simultaneous equations, and we only want to know the x ordinates, so we don't actually need to find the respective y ordinates. Then we've got our two equations, where this equation here is our linear equation, and it says in the answer give your answer to one decimal place. Now what that one decimal place means is that when we're going on to solve the quadratic, which we evidently will do, we need to use the quadratic formula. So we're not going to use factorizing to solve this, because in the question it's told me to give my answers to one decimal place. So let's go about doing this. So step 1, have we, in the linear equation, have we got one letter as a subject? Yes, we have. We've got y the subject. So what I then need to do is substitute wherever I see a y in the nonlinear equation, I swap that with 4x plus 2. So what I end up with is 4x plus 2 equals 3x squared. I'm then going to take this over to the other side. So that becomes 3x squared minus 4x minus 2 equals 0. And then from this, I'm then going to use the quadratic formula to then go on to solve this quadratic. So a equals 3, b equals minus 4, and c equals minus 2. So then substituting this into the quadratic formula, I end up with minus, and then it's minus 4 plus or minus the square root of minus 4 squared minus 4 times a times c, that's all square rooted, all divided by 2 times a, which is 2 times 3. Now, again, you could try typing that all into your calculator, but I would say that looks very messy, and depending on how good you are using your calculator, it's very easy to make a very silly mistake and not know about it. So here, let's just try and simplify this in its essence. So minus 4 becomes positive 4, then we've got a plus and minus, then we've got a square root. Now, minus 4 squared is 16. And then we've got 4 times 3, which is 12, times minus 2 is minus 24. So we get minus 24. And 2 times 3 is 6. So then simplifying the square root, I end up with 4 plus or minus. And then 16 plus 24 is 40, all divided by 6. So then from this, what I then need to do is set up my calculator and just enter the two numbers in. So let's go for minus first. So 4 minus square root of 40 divided by 6, press equals, press the SD button, and I get an answer to one decimal place of minus 0.4. And then to work out the second answer, you can either type it all again, or you can just go and delete the minus and put a plus, and then press the SD button. I get 1.7. So my two answers then are 0.4 and 1.7, and they've been rounded to one decimal place. Moving on to question 3, it says solve the simultaneous equation. So it says you must show you're working out. So for this, and it's worth 5 marks again. So again, we've already got one letter to the subject, so that's where the 6 marks would come in if I do some rearranging. So here, this is my linear equation. And so wherever I see a y, because that's the subject, I'm going to swap that with 4 minus x. So doing just that, I end up with 4 minus x equals x squared minus 6x minus 20. Now you can see here that in this question there's no mention of rounding, so odds are I'm going to be solving by factorizing. So I'm going to take this over to the other side. So I end up with x squared, and then it's going to be minus 5x, and then it's going to be minus 24, because I'm going to be adding x and taking away 4. So minus 6x plus x is minus 5, and minus 20 minus 4 is going to give me minus 24, and that equals 0. So from this, what I need to do is try and find two numbers that multiply together give me 24, and add together give me 5. So I'm going to go for x, and I'm going to go for 8 and 3. And it's going to be a minus 8 and a positive 3. Always make sure you're writing equal to 0. So then looking at this, I've got my two x values, which is going to be minus 3 and x equals positive 8. So they're my two x ordinates. So now I need to do is find my y ordinates. So using y equals 4 minus x. So when x equals minus 3, I end up with y equals 4 minus 3. So it equals y equals 7. And when x equals 8, I end up with y equals 4 minus 8, which equals minus 4. So my two answers then are x equals, no, let's write this, yeah, x equals, don't know why I've wrote a bracket there, so let me just get rid of that. So this doesn't refer to a graph, so I don't need to write my answers as coordinates. So when x equals minus 3, y equals 7. And when x equals 8, y equals minus 4. And there is my final answer. Now again, if I wanted to write it as a coordinate, I shouldn't really lose any marks. But again, because this doesn't refer to a graph, you want to write these answers as two sets of numbers. Just make sure that the respective x goes with the respective y. That purple is not a good choice, so let me just get rid of that. Oh. And let's go instead. There we go. Moving on to question 4 again. So again, worth 5 marks here because there's no rearranging of the linear equation. So here, let's have a look. So this is my linear equation. I've already got y, the subject, so I just need to substitute it in. So I've got 4x plus 1 equals 2x squared plus 7x minus 1. So taking all of this to the other side, we end up with 2x squared plus 3x, and it's going to be minus 2 equals 0. And then all we then need to do is then factorize this. So we get 2x, x, and then we're going to have 2 and a 1. That's going to be a plus, that's going to be a minus, and we equal 0. And again, if you're struggling in terms of factorizing a complex quadratic, again, just do a bit of revision. You'll find out a way that works for you. You can either do it by doing it in your head, or there is a set method using a magic number method. So from this, what we then get is x equals, and it's going to be a positive 1/2 or minus 2. So there are my x ordinates. And from this then, we then need to use the linear equation of 4x equals 1. So when x equals 0.5, then we get y equals 4 lots of 0.5, which is 2 plus 1. So we get y equals 3. And when x equals minus 2, we get y equals 4 lots of minus 2, which is minus 8, plus 1, which equals 7. So my set of answers are x equals 0.5 or 1/2, and y equals 3, and x equals minus 2, and y equals 7. Moving on to question 5. So this question is worth 6 marks, and again, hopefully you'll be able to see why. So it says solve the simultaneous equation, and we've got 4x plus y equals minus 3, and y equals x squared plus 2x plus 5. It says do not use child improvement, so do not guess, and you need to show you're working out, obviously, and it's worth 6 marks. Don't worry, I've just crossed that out because I was hoping it was a highlighter. So let's just go on there. So then from this, we know that this here is our linear equation, and this here is our non-linear equation. So looking at 4x plus y equals minus 3. Now looking at which letter I'm going to choose. Now you want to go for the one that is single already. So here I've got single y, so I'm going to make y the subject. So how do I do that? I get rid of the 4x and take that over to the side. So I end up with y equals minus 3 minus 4x, which does not look nice at all, but this is why the question is worth 6 marks. So what I'm then going to do is I'm going to substitute this into my quadratic equation, or the other nonlinear equation. So I end up with minus 3 minus 4x equals x squared plus 2x plus 5. And then what I'm then going to do is I'm going to take this over to the other side to try and keep the x squared positive. So I end up with x squared, and then I've got 2x plus 4x, which is 6x. I end up with 5 plus 3, which is 8. And then from this, I then want to factorize because there's no mention of rounding, so it is going to it should factorize. So here I've got x and x, and I'm going to be using 4 and 2, and both of them are plus. So this is going to give me an x value of minus 4 or minus 2. Again, if you want to use the quadratic formula, you can do, but again, it does factorize, so we can factorize. So once we've got x values, then we want to substitute it into our linear equation. Now you've got a choice of linear equations you can go for. You can either go for the original or you could go for our rearranged version. So it depends on whichever you prefer. I would say probably go for the rearranged version just because we've already got y the subject. So y equals minus 3 minus 4x, but we are dealing with negative values a lot. So when x equals minus 4, then what we end up is y equals minus 3 minus 4 times minus 4, which equals y equals minus 3 plus 16, which gives me 13. So one of my set of answers is when x equals minus 4, y equals 13. Then when x equals minus 2, then y equals minus 3 minus 4 lots of minus 2, which then becomes y equals minus 3 plus 8, which equals 5. So then when x equals minus 2, y equals 5. And there is my second set of solutions. Moving on to question 6, it says work out the points of intersection of the graph. So again, this is then therefore basically saying that we need to write our answers as coordinates. So write answers as coordinates. Now, would you lose marks if you didn't? I'd probably have to look at the mark scheme, which is included in the question sheet. But again, I know that we do need to write coordinates, so that's what I'm going to go for. So again, looking at this is my linear equation. This is my nonlinear, which is nicely already factorized for me. Not that it's going to make a difference. And again, it's worth 6 marks. So from this, we've already got y the subject. So just make the two equations equal to each other. So 4x equals, and then x plus 3, x minus 5. Now I would expand the brackets out, even though we're going to have to factorize again because there's no mention of rounding. So that's going to be x squared minus 5x plus 3, so it's minus 2x, and it's then going to be minus 15. So then taking this all over to the side, we end up with x squared minus 6x minus 16 equals 0, and then we factorize it, and we're going to go for 8 and 2, and we've got minus and a plus. So x equals minus 2 and x equals 8. So then using the linear equation, so using y equals 4x plus 1. So when x equals minus 2, y equals 4 times minus 2 plus 1. And that's going to be minus 8 plus 1, which equals minus 7. So here, one set of answers is x. Well, let's write its coordinates. So here, so y equals minus 7. So I've got minus 2 minus 7, and when x equals 8, then I end up with y equals 4 times 8, which is 32, plus 1, which is 33. So then from this, my second coordinate then is going to be 8 and 33, and there are my coordinates of interception. Now, because we end up with two solutions, it basically means that the parabola and the straight line are going to intercept at 2 points. Moving on to question 7, it says solve the simultaneous equation, and it says give your answer to 1 decimal place. So again, this therefore means we need to use the quadratic formula, and it's worth 6 marks, which means we're going to have to do a bit of rearranging. So looking at the linear equations, let me just highlight that. Now, you've got a choice of which letter you want to make the subject. Now, if I take the y over, then I'm going to end up with x. Let's just do that. So let's look at this. So if I take the y over, I end up with minus x equals 2 minus y, which is not the nicest because my x is negative. Another alternative is if I make y the subject, then I end up with 2 plus x, which looks a lot neater. So I'm going to go for that version there. So then making y the subject, I then substitute it into the nonlinear equation, so just make them equal to each other. So I've got 2 plus x equals 2x squared plus 5x plus 1. Then taking all of this to the other side, we end up with 2x squared plus 4x, and it's going to be minus 1 equals 0. So then what we need to then do is factorize this. So we get 2x, x or actually we don't factorize, again going against what I've just said, so it's important to read the question. So from this I'm going to go straight into using the quadratic formula. So I've got a equals 2, b equals positive 4, and c equals negative 1. So then from this, substitute this into the quadratic formula. So I've got minus 4 plus or minus the square root of 4 squared minus 4 times a times c, 4 square rooted, or divided by 2 times a. So from this, let's just simplify this. So I end up with minus 4 plus or minus. 4 squared is 16. And then 4 times 2 is 8. Times minus 1 is minus 8. So I've got minus 8. Or divided by 2 times 2, which is 4. So I end up with minus 4 plus or minus 16 plus 8, which is 22. No, it's not. It's 24. And all divided by 4. Now from this is what my x values equal. So if I then go reach for my calculator and let's just type that in, so I end up with minus 4 minus, let's just go for the small answer first, so 24 over 4 equals, and it should give me minus 2.2. so x equals minus 2.2. And then if I go back to the calculator and then just change that minus to a plus, and I've got 0.2. And then from this, what I'm then going to do is substitute that into the linear equation. So here, so using y equals 2 plus x, so when x equals minus 2.2, y is going to equal, well, if I just add 2, then that's just going to be minus 0.2. And when x equals 0.2, y is going to equal 2.2. So then my two answers therefore then are going to be that. So that's one set of answers, and that is another set of answers. What we also want to try and do is not write over your answer, and so let's just leave it as that. So then moving on to question 8, which is very, very similar to question 7. However, looking at this equation, we've got to give our answers to 2 decimal places this time. So looking at this, looking at the equations, we don't need to do any rearranging because they're both equal to y. So let's just go straight into the answer. So we've got x plus 4 equals 2x squared plus 3x minus 1. So then taking everything all onto one side, we end up with 2x squared, and then it's going to be plus 2x, and then it's going to be minus 5 equals 0. Now because it mentions rounding, I'm going to go straight into using the quadratic formula. So let's just write that down there. So here we've got a equals 2, b equals positive 2, and c equals minus 5. So substituting this into the quadratic formula, we end up with minus 2 plus or minus square root of 2 squared minus 4 times 2 times minus 5, all divided by 2 times a, which is like so. So then let me just close that bracket. So let's just neaten this up. So I end up with minus 2 plus or minus 2 squared is 4, and then 4 times 2 is 8, times minus 5 is minus 40. And that's all divided by 4, which leaves me with minus 2 plus or minus 44 over 4. Now again, if any of these you don't want to do in your head, you want to use your calculator, that's fine. But just bear in mind that you want to make sure you're getting the right answers, because messing it up at this stage is going to cost you a lot of marks. So from this, I can then type that in. Now I don't need to simplify any thirds. I'm just going to go straight into using my calculator. So here I've got minus 2 minus. Now if you start with the minus, the odds are you'll end up with the smaller answer of x first, or y, whichever you prefer. And then we divide that by 4, and I get an answer to 2 decimal places of 2.16. So here we've got x equals minus 2.16. Then looking at the next value, so if I just change that negative into a plus, press equals SD, and we get 1.16. So these are my 2 x values. So then what I then need to do is substitute it into the linear. So here using y equals x plus 4. So all I'm doing is adding 4 to each of those answers. So when x equals minus 2.16, y is going to equal 4 plus that, which is going to be 1.84. And when x equals 1.16, y is going to equal 5.16. So they're my two set of answers. So here I'm going to write x equals minus 2.16 and y equals 1.84. And when x equals 1.16, y equals 5.16. And that should be fine, because again, if you want to highlight it each, then just underline it with a single line, but that should be fine in terms of that. You can also do a little arrow just to make sure that you can see that they are linked. But I would say if you write it on the same line, it'll be pretty harsh for you to lose marks. As long as your answers aren't scattered all over the place, so it's a bit like a treasure hunt, you should get the 4 marks. So moving on to our last question, it says solve the simultaneous equation, and it says do not use child improvement. So we have to use the method of simultaneous equations. So again, looking at our linear equation, we haven't got letter to subject, so let's pick one. Now it doesn't really matter which letter you go for, but again, because we've got y squared the subject in this equation, you may want to be tempted to work with y's, but it shouldn't really make a difference. So with this, I'm going to make it as y equals 4 minus x. So if I substitute this into the nonlinear equation, I end up with 4 minus x squared equals 4x plus 5. Now, if I went for the other option of making y the subject, x the subject, I'd end up with x equals 4 minus y. And then substituting into this, I end up with y squared equals 4 lots of 4 minus y plus 5. Now, either way, I'm going to have to expand the brackets, and it's entirely up to you which one you prefer. So using the one that's written in blue, you'll find the y ordinates first, and one writing in green, you'll find the x ordinates first, and you can choose which one, but you should still end up with the same answer. So I'm not going to go through both because I don't want to prolong the length of this video. So let's look at this. Now, the key thing to remember with this is that this is double bracket, so it's 4 minus x, 4 minus x. So if we expand that out, we get 16 minus 8x plus x squared equals 4x plus 5. Then if we take all of this to the side and just rearrange it, I end up with x squared minus 12x and plus, it's going to be minus 11 equals 0. So factorizing this, I end up with 11 and 1, and that should be a plus. And so then it's going to be both minus equals 0. So here my x is going to either equal 1 or 11. So then using this, and then from this, let's just go back, change colour. We've got x plus y. Well, let's go for the rearranged version. So let's go for that instead. So here we've got y equals 4 minus x. So here when x equals 1, then y equals 4 minus 1, which equals 3. So that's one coordinate. And let's just put a little box around there. And when x equals 11, then y equals 4 minus 11, which equals 4 minus 11 is going to give me 7. So minus 7. And so here, there's my other set of answers. So looking at this, x equals 1, y equals 3, and when x equals 11, y equals minus 7. And there is my final answer.